initial condition, you not only have to find y, you have to find c as well, correct?
Yeah.
Same as we've been doing. This is the initial condition to find c. So here's what I need to do. I need to use this differential equation. The goal is to go backwards and find out what y is. But I need to get my variables on one side. So I'm going to go ahead and save that as x squared, y squared. Right? Multiplication, I am allowed to distribute that power. Now, always take y to this side. Because think about it. First things first, multiply both sides by dx. I'm going to have dy equals x squared, y squared dx. You always want dx on this side because you can just simply multiply both sides by it, correct? You read that fraction? Now I need to get this to the other side. So I need to divide by it. Right? 1 over y squared dy, x squared dx. Then we'll follow that I divided by y squared. Huh? That right there is actually sometimes the hardest part, getting the y's and x's on separate sides. That's why it's called separation of variables. You separate the x's, you separate the y's. Exactly what we're doing. Okay? Sometimes that is the hardest part algebraically. But once you have this, you now integrate both sides. Now that is y to the negative 2, so my antiderivative, add 1 to the power and divide by it, will be negative 1 over y. You want to follow that? Antiderivative over here is
1/3 x.
1/3 x cubed. Now, I'm going to put a plus c. Here's why I didn't on the other side. Let's say I put a plus k on this side. Can I subtract k from both sides? That would still be a constant, correct? If I have a constant on both sides of an equation, if I take it over, I still have a constant. There's no need to introduce two different constants. That doesn't work if you do that. Okay, because it's still a constant. And that is a key thing we need to focus on. Okay, so on these steps here, I've integrated both sides. I need to solve for y. Once again, it's a lot of algebra. Right here, I would cross multiply. Right? Negative 1 equals y times all that stuff. Divide by that. I don't like that being on the other side. So y is really negative 1 over 1/3 x cubed plus c. Divide by all that junk. I switch sides too. I don't like my y being on the other side. Now, you usually will not see it like this because people do not like that fraction. How could I get rid of that? Oh, no, 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 don't KFC. Don't you dare KFC because there's addition going on, correct? Don't you dare KFC.
You can times everything.
Times everything by 3 over 3, correct? That's 1.
1 over 1/3 is 3. That's what we.
What?
1 over 1/3 is just what I'm saying.
But you've got that plus c. No, it's not the same. Because we need to talk about what's going on here. If this was anything, that's going to change your constant, though. Now, I know you guys are thinking that because this is a 1. That's the only reason that works, okay? Not the same, guys. Not the same. You cannot KFC algebraically. That is incorrect. You cannot divide before you add. It's order of operations. Right? My poster's covered up there. So you think, oh, I got the same thing. No, you still did it wrong. You wouldn't get any credit. Okay? So anyway, when I distribute this 3, 3c is still a constant, correct?
Yeah.
It's a different constant, but it's still a constant, right? So we kind of just keep it as c. We know it's really not the same thing we started with, but it's still a constant, so I don't really care what it is. Does that make sense? Okay, so there's my y. There's part of the answer. Now I'm going to use my initial condition and solve. What was my initial? 1 and 1?
Yeah.
So y is 1 when x is 1. Okay, let's cross multiply that. So c is negative 4. Like I said, a lot of this is algebra because a lot of people don't know how to solve that, believe it or not. If I didn't put that over 1, a lot of people get stuck stuck. That is just straight up cross multiplication, which we will do a lot in this section. Oops. So now I have y equals negative 3 x cubed minus 4. There's my answer. The actual calculus is not hard. Usually, when you integrate, they're usually pretty easy to integrate. Now, we might need a little substitution occasionally, but they're usually pretty straightforward. It's the algebra that we can get lost in. Yeah?
Out of curiosity, why would you not need to divide the c by 3?
C by... Oh, I got what you're saying. Because it's still a constant. The fact that we multiply by 3, it's still a constant. So, this whole initial condition, go ahead and do it at the end, because it's still a constant. If you kept that 3 in there, it would have given you a different c, but when you plug, yeah, let me say play it that way. If you would have kept it as like 3c right here, hypothetically, you could have solved it and plugged it in, but then you'd still get negative 4 for that whole term. You would have gotten here like negative 4/3, which then when you multiply by 3, you would have, I mean, so it would have worked the same, just would have been more complicated. Yeah. That's a good question though.